The renewable energy sector is looking to robotics and artificial intelligence in order to tackle life cycle barriers which have impacts on the safety of workforce, productivity of an asset, and operation and maintenance.
For offshore assets, unaddressed or unforeseen problems can accelerate loss of revenue, leading to expensive stoppages and extensive repairs. Therefore, inspection, maintenance, and repair techniques are essential to prevent this.
Operation and maintenance of these large offshore wind turbines can be time-consuming, costly, and requires ideal weather conditions. The deployment of robotics reduces the risks of these challenges, whilst increasing the safety of the skilled workforce.
For inspection, maintenance and repair, we need to grow autonomy by addressing barriers in reliability, functionality, resilience, and safety.
Currently, mobile robots often execute demonstrations flawlessly due to close supervision from human operators and short-term missions which are limited to mostly inspections.
However, to achieve high impact from regular deployment of robots in this field, a non-intervention challenge exists to reduce human intervention during autonomous missions where robots fail.
We identify symbiotic multi-robot fleets as key elements in the optimization of autonomy as a service, where a diverse multi-robot fleet can leverage the capability of autonomous missions.
We require solutions tailored to the mission and the intrinsic limitations of current commercial off-the-shelf robotics. We present a symbiotic multi-robot fleet, or SMURF, where a quadruped wheeled robot, UAV, and a series of infrastructure monitoring systems are designed to cooperate, collaborate, and corroborate within a confined space inspection, maintenance, and repair mission.
The orchestration of the SMURF is implemented via symbiotic digital architecture that permits near-to-real-time collaborative governance for up to 1,600 distributed assets via bidirectional communications.
This approach to a multi-robot fleet was evaluated in a synthetic environment which represented an offshore substation as to safely evaluate more dynamic mission scenarios and failure modes in a representative way.
The results include symbiotic interactions across the SMURF, which enable for mutualistic gains across human and machines, positively disrupting robotics and artificial intelligence.
How we address safety, reliability and resilience has a direct impact on the regular deployment of robotics and artificial intelligence in dynamic environments sector-wide. A SMURF, which utilises symbiotic interactions, leads to human-robot partnerships where a hyper-enabled overview is achieved within beyond visual line of sight missions.